video, we're going to go over how to solve problems using the central limit theorem. So the central limit theorem for means states that for all samples of size n with n greater than 30, the sampling distribution of the mean can be approximated by a normal distribution with mean for our population mean and standard deviation will be population standard deviation over the square root of n. So the mean of the sampling distribution is going to equal the population mean, and the standard deviation of the sampling distribution, or the standard error, is going to be standard deviation over square root of n. Remember, we can use the central limit theorem when our sample size is greater than 30, or if the original population comes from the normal distribution. So let's go ahead and move on to our example. So this tells us, based on data from the National Health Survey, women between ages of 18 and 24 have an average systolic blood pressure of 114.8 with a standard deviation of 13.1. And it tells us that systolic blood pressure for women between the ages of 18 to 24 will follow a normal distribution. So we can use the central limit theorem because this follows a normal distribution. So we have our problem number 1. If a woman from this population is randomly selected, find the probability that her systolic blood pressure is greater than 120. So this is just any single woman in this group. So we don't have a sample, we just have one. So we're going to go ahead and put in our mean. And we're going to go ahead and put in our standard deviation. And then we want greater than, and we want 120. And make sure you're on the find probability tab. So we can see that there is 34.5% chance that this randomly selected woman would have a blood pressure greater than 120. Now the next one tells us we have 40 women. So we're selecting 40 women. This is a sample. We want to find the probability that their mean systolic blood pressure is greater than 120. So this time we're going to have to use the central limit theorem. So the mean of the sampling distribution will equal the population mean. So our mean is still going to stay that 114.8. But you can see for our standard error, we're going to have to take that 13.1. We're going to have to divide it by the square root of our sample size, which is 40. So let's go ahead and do this in this calculator. We have 13.1 over the square root of 40. And we get this number here. So we usually want to round this to around 4 or 5. So let's just go to here. And we're going to put this is going to be our new standard deviation because this is our standard error. And we are still looking for greater than 120, so greater than 120. And we get a 0.6% chance. .6% chance. Now, why is this percent chance so much lower? That's because we're not just looking at any one random woman. We're looking at if we take those 40 women and we take the average of them, that's going to be probably a good chance that it should be close to that average. And our average was 114.8. So 120 is all the way up here on our normal curve, so it's much higher than we would think our average would be down at the 114.8. And that is how you solve problems for the central limit theorem for the mean.